Okay, you'll be glad to know there's not going to be boring PowerPoint presentations anymore. So we're just going to dive into the actual SQL stuff. And today's session is about basically, what was that, 7 topics. No, 6 topics. Aliases and expressions in SQL's select statements. So this is just basically a good practice of actually naming your tables from which you select properly so that you can reference them within the actual SQL, and naming the columns as well properly. And I'll kind of explain what the reason for it. And it's a really good idea to always give alias to the tables you're selecting from, and always give proper aliases to the columns that you're actually outputting as well. The next topic is going to be ordering. So this is just order by, but there are some interesting things. We can have a look at execution plans when we order columns. Selecting a specific range of rows from your select. We can do that with the top clause in SQL Server. Then we're going to look at subquerying. So we can basically create a query, and we can, instead of using tables directly, we can create queries and basically reference them as if they're tables. Then we will look at how we can select a specific range of rows from your select statement based on the row number. So we can give each row a specific number, and that allows us to do, that allows us to select a specific range within a select, and almost to do like a paging in on the website. For example, when we want to present data on the website, instead of just displaying the whole range of things, let's say we need to display rows from 100 to 150, and you could do that with a row number. And then finally, we're going to look at group by. And this is where things get really interesting once we start doing the aggregation. Everything else is pretty much easy. The only thing that we are really going to be interested in is every time we execute a query or we write something, we're going to look at the execution plan and see what's actually happening and run it as well. Because I think that's more important than actually knowing this is how I'm doing select star from a specific table. Hey, there you go. But what's actually what the server is actually doing? That's interesting to look at. Okay, so the database we're going to be using is AdventureWorks, as usual, and primarily we're going to be, the structure of this specific lesson is going to be, we will take a product database or product table, product inventory and locations, and we're going to start basically building it up into a more or less bigger query. Okay, all right, let's get going, and yeah, I think so. It's there. Okay, cool. So when we want to select the data, obviously we write select star from, and then table name, product, for example, production product, and we select all the data. Okay, first of all, very bad idea to do is in any of your queries to do select star. The reason for it, because there might be a lot of columns in the table. And if you actually done lots of inner joins, so you joined a lot of tables in, the server would have to pull all this information as an output set, which means that it gets loaded a lot. So always kind of restrict to what you actually want to select. And another bad idea, another reason for select star being sort of a bad idea is when you're actually trying to use this query in your code, for example, in C# or like a web service, etc. The client that actually consumes that query doesn't know what sort of columns you're actually returning. So it's a really good idea to kind of restrict exactly what columns you want. And another really good thing I'm going to do is I'm actually going to include the execution plan in every query straight away, right? So if we look at the execution plan when we're doing select star from a specific table, it's actually a very simple execution plan. If I move on to it, you see it doesn't even have the output expressions, because I'm simply selecting everything. So it just basically dumps everything out of this query and then redoing basically the select from it. If I then restrict it, let's say I want only product ID, transaction, product ID. Look at the execution plan. Now we have the output list, which means that when we actually scan in the table, we only output in a specific it's called attribute out of the relation, actually. So it makes the actual select basically performing a lot less work. Okay, but that's basically just about like doing the select star, and it's, always general sort of guidance is always actually specify what columns you actually want to select from a table, unless you're doing some really kind of basic querying on database to, I don't know, to bug some ticket or something. You just want to get some data out very quickly, have a look at it, etc. If you're actually using this query in any of your code, do it properly. So when we write query, we can actually give this selection table from which we actually select an alias, which means that we're going to refer to it as something different. For example, if I just put prod, then immediately I don't have to reference this table from which I'm selecting from by its full name. I can just say prod in there. So we specify which table we want, and then we say know this table as prod in my query. So now I can reference it by prod. By the same token, so if we just execute it again, execution plan is exactly the same. It's just for ease of referencing it within the query. By the same token, I can give each single column that I'm selecting a specific name. So I can say product ID is going to be prod, just basically an ID. When I'm selecting this data, my column is now called ID. Right? So I'm going to be typing a lot during this section, so bear with me. Production, product. Okay, we'll give this alias prod in a join. And what we're going to join it to is inventory. Yeah, product inventory. Again, give it a specific name. And here, instead, what I'm going to do, I'm going to make it fail. Okay? So, now, let's just comment that out. In this query, basically, I know that there's, in my product table, there's a product ID column. And if I execute this query, it'll be absolutely fine. Look. Then, if I then add product inventory, I'll give it a specific alias, and then I will join it to product ID, and then product ID. If I try to execute it, it tells me that there's an ambiguous column named product ID. That's because product ID exists in product and product inventory. This is really good to actually, well, it's really good. It's you must specify the exact column or the exact table where that column is being pulled from. When you have a static tables like this, then it's not really a problem. Even if when you went and modified it to add it in a join to it, it's still kind of fine. Well, it's still kind of fine because once you modified it, it will fail. It'll tell you need to specify a specific table name. But when you actually working with dynamic queries, when you building those queries up in your code, then it might not be obvious. So when you build in the dynamic queries, you absolutely must specify which table you actually want that column to come from. Otherwise, you're going to get an error. At some point, you might not even realize that conflict happened at some point once you build up the query. All right, so already said we can give. Okay, we want product, we want color, and you know what? In my code, for example, I don't want to reference color as color. Maybe I have another query somewhere down the bottom where I have another field for color. I don't know, maybe we have a warehouse or a location somewhere. Let's just add in production to replicate this scenario. Unfortunately, IntelliSense in SQL Server stops working once you screwed up your query a little bit. Location. Location ID is brought. No, actually, that is in an inventory by location ID. And what I'm going to do something. I'm going to add color. The color, it is color. It's varchar 24. To product location. Did it execute? No. Okay, now I want to kind of output product color and location color. Which I can do in SQL Server, it's absolutely fine. I have two columns named color. So if I then try to reference this column from my code, then basically the code wouldn't know what the hell I'm actually talking about. There's two columns called exactly the same thing. In fact, your query execution might even fail because it will then try to put it in the array. And because there's a duplicated key, it will fail. So in this circumstance, it's a really good idea to kind of rename the color, or the name, well, the column that you're actually outputting, and give it a proper reference. And we do that by basically specifying, actually we're doing it differently, doing it like this. New name equals what column. That's it. Okay, generally when we work with any queries, it's a really good idea to kind of keep it to a specific standard, and the standard is always give every table you reference in a alias. Don't just leave it as product or production product inventory. This makes it very difficult to reference it within the query. It also makes it safer if you're trying to change this query. And you know, it's a really good idea to never use select star in any of your queries. That's just dumb. And obviously, when you need to change the names of the columns, do change them like this. Okay, from execution point of view, we don't have anything interesting to say here yet. But what we can start doing is we can start looking at the expressions and see generally how the execution of those queries actually work. So what I'm going to do is I'm going to get rid of the location color, and I'm going to select the name of the location. Let me just execute this and see if we get execution plan. Oh yes, cool. Now, interesting thing to note, to mention about the execution plan is, although we have included the location into the query, right? You would have expected that SQL Server would, scan that table somehow and do something with it because you actually referenced it in your query. But in fact, if we look at the execution plan, well, it didn't even reference this table anywhere. So at this point, we just have the scan on product table and scan on product inventory table, and we're doing a merge join with them, and that's about it. So we're not actually using the location table in any way, although we even included that. This is basically to save time because we haven't actually used any of the fields from location. SQL Server is smart enough to know that since, even though we have included this table in our inner joins, we actually join into that table, but we're not using any data out of it, so we don't need it in our scan, so we don't see it there. Once we included location, let's say name, now we scan it, we look at the execution plan, it changed dramatically. So you can also notice that it changed quite dramatically in the sense that it actually, from my point of view, it's doing this execution incorrectly. For example, well, that's, hang on a second, is this, yeah, this is location, and then it's, oh no, that's actually correct. Okay, so we now have a this join happening first, so well, almost like first. This join happens separate from this one, so we know that we need to join product inventory to location because there is a product, there's an inventory in every single separate location. So we're joining that, we're doing hash match on them, which means that we're going to select all the rows out of this table. And then all the rows out of this table will hash their IDs, and we want to match them together, and we'll produce a specific output that we can reference in this table. Then we scan all the products, and then we basically match what we have inventory for, and then we're just basically selecting an output. Okay. We can then start adding a where clause, where we can sort of limit the data, say by saying that I will only want to see products that are black. Our execution shouldn't really change at this point. Did it change? No. But we now, compared to the previous one, we're now spending a lot more time, well, not a lot more time, 1% more time, on actually scanning. What do we need? Yeah, on actually scanning the product table. Now it's 16%. Now if I include the product table, it's a little bit more. Since we now have a predicate called color, only select the rows that are color black. Let's include some more to start looking at. More than 4. So what we're going to do is actually select all the products where inventory is in any location is more than 4. So again, select that. And well, our execution plan hasn't really changed, but we now have a predicate in our product inventory scan, where we now limiting the rows that we're outputting with. Unfortunately, I can't move the mouse over this. Oh, come on. With basically saying that, yeah, the first statement over there is select from a specific table where specific attribute is more than 4. So it makes the query a lot lighter. Okay, we can, in our select statements, we can do expressions. Actually, in any of the predicates, we can use expressions. Expression meaning that we can combine two columns, we can do some functions on the attribute itself. For example, we can say inventory quantity plus 1. And we can give this column a name, 1 inventory. Okay, and now we have, let's just output the column, inventory quantity as well. Okay, so that's very basic explanation of what the expression is. So we can do some math on top of the attribute, on the attribute itself, or we can do some math on any of the predicates. So for example, I can say, you know what, I want to match every product to every product in my inventory database where product ID is plus 1. So basically almost like a next product. And there you go. So it's going to be a bit of a mismatch of the products in the inventory. Okay, I can combine several columns. Let's, for example, say I want a product name, or actually product in location, let's call it in location. And we can do this. Product name, product it's title, isn't it? No. Name, I think. Name plus something like this, plus the location and name. So I'm just basically combining two columns together, produce an output, there you go. There are expressions that effectively act as, well, that are functions. So I can say, like, give me a character index. In fact, let's do something different. Substring. Substring is a very common thing that we use in SQL, I mean in C#, for example. We say, I want a, from product name, I want first character only. So they are expressions, and we can use them in any of our predicates as well. So for example, here I can say where substring color equals B. So I'll give me all the black and probably some blue ones. Yeah, okay. All right, so we've written all this, and now have a look at the execution. In fact, let me just rewind this all the way back so that we can start looking at the execution plan and see where we actually, where the SQL Server deals with the expressions in the first place. Kind of deals with them in two places, really, but okay. Okay. At the moment, I don't have any expressions in any of my in any of my attributes or any of my predicates. But now, if I do this, inventory quantity, so add an expression to the attribute output, +1. Let's look at the execution plan. Now we have a new element in our execution plan, compute Scalar. Compute Scalar meaning that we're gonna take the output columns from our relation, and then we're going to do some basically math. So we will effectively will take quantity and +1, and we will output it as an expression. This is what we can see in the compute Scalar. So we take the original output, which is from which table is this? Product inventory, where quantity is equals 4. We output all the values that we need in our query. So in this case, that will be product ID, location, because we need product ID to match it to a product table, and then location ID to match it to a location table. And then we also need quantity, because we actually use this in our expression, or we use this in to actually output this in our field. Then we take this quantity and we're doing a computation on that attribute, so we add in 1 to it, and we almost like including this as an output. Out of both of those, we will have 2. And in here we should be able to see. No, we can't see it there. No, forget it. Okay, so by the same token, I mean, if we start doing things here, like say quantity +1, so in my predicate I'm start using the expression, I'm pretty much going to see exactly the same thing. No, we don't. Okay, it's basically smart enough not to do the Scalar output and then use that as a select. It can just basically include this in the actual predicate itself, so it knows that quantity +1, more than 4. But if we do it here, I think this is where we're going to see Scalar computation. Exactly. So when we output in the product IDs out of the product inventory, we now have to use an expression effectively, and we have to compute that expression first before we do this thing. As you can see, now our query has changed as well. This is an interesting one. Previously, we're doing a scan on a location table, then scan on a product ID table. We get all the data, and we're doing a hash match, which is fast enough, because all we're doing is we basically hashing all the data by product ID and then matching them together. And if we add something stupid like this, our execution plan changes to a nasty thing called nested loop. Okay. Because we're no longer using a index field out of our product inventory, we can't do a hash match. Well, SQL Server estimation thinks that it might not be wise to do a hash match. Instead, what it's choosing to do is to do a nested loop. So if we go, for example, in my case, looked at this execution plan. I have no idea what nested loop is. It just appeared in my screen. What is it? What does it do? So let's just go on to Wise Google and ask, what the hell is nested loop SQL? So that's how my girlfriend asked question from Google, but that's not right. I think we could just do this, and we're going to be a lot smarter. So we can go and read a little bit about it, what it does actually do. But in essence, what it's doing, in a nutshell, of course, it's a little bit more smarter than what I'm just going to explain. But it's taking every single row out of your which one is this? Out of your product. Did I actually change the order down? Okay. All right. It takes every single product out of your product table where color is black. Then compute its Scalar expression, product plus 1. And then for every single one of those rows, it'll go to this table, which is product inventory, and scan that table. And we can see right there where it says number of executions. Can you see it in that list there? So number of executions, it'll scan it 93 times. So for every single product, it will go to product inventory and scan that table again. Then it will take the next row and scan that table again. It's a pretty nasty thing if you think about it. The number of scans it's actually doing per table. Of course, we're using a clustered index. For those who know about indexes, we'll talk about indexes in the next session. But if it uses a clustered index, it means that it knows exactly where to go on a disk to pick that record up, or maybe the whole table is cached in memory, so you can get to it very quickly. But still, this is only 93 executions, but imagine if we had a couple of million products in our table, and we would have to do a couple of million executions on the product inventory table to get every single row out. It's quite expensive computationally. So silly things like this can cause your execution plans to go absolutely nuts. So, think about when you're doing the expressions that it's what's happening. There's no magic happening. You actually selecting tuples from your relation based on some predicate. And then you're taking all this data, you're doing further computation on this, and then you take that data with that computation and push it forward down the pipe. That's all that happens when you use expressions. Okay, let's move on. All right, so now we've got this execution plan, and you know what? SQL Server might have thought that we're getting somewhere with this stuff, and it might have cached this execution plan, which means that when we were playing around with all these expressions, it might have actually cached something and went like, oh, you know what? Next time we're going to use nested loop for every query that you're going to run. It's not the case in this specific circumstance. It kind of reverted back to actually using a hash match, which is kind of better. But in case it does this, in case it caches your execution plan, we can specify an option in our query. Recompile. Let's see if I can get it from the fourth time. Recompile. Oh, there you go. Hey. If you specify recompile, basically it dumps the previously cached execution plan, and it just basically redoing the execution plan based on estimation of number of rows in every table and all this kind of stuff. So it does the computation every time. Okay, so the next one is ordering. So for the sake of this demonstration, I'm going to leave this option in place all the time. Looking at the time, I don't think we'll be able to go through all of them, but we're going to move everything to the next session then. Okay, ordering is pretty simple. Because we can take this data that we've got there and order it by a specific field. So to do this, we just put order by, at the end of our query, let's say I want to order it by inventory quantity. Okay, so we order it by quantity. Let's move one of the columns. It's daft to have two columns at the same time. So it orders everything by quantity. I can reverse this order by putting descending order on quantity. So we're going to have the highest number at the top. I can order by multiple columns as well. So if I say I want to order it by product name first and then quantity. So we now have, do we have product name in here? Yes, we have product name. There's probably different quantities in different locations, and every single product itself might be a different product. Oh yes, indeed. Product name. Okay. So we've got one product that is in different locations, and we then further ordering by that. Again, if we just basically go and look at the execution plan is very simple. Now we don't have location, so we got rid of the location scan from this query straight away. Okay, everything up to, before this statement we added in is exactly the same. We're doing some scan on the product table, some scan on the product inventory table, we're joining that, and then we're doing sort. As you can see, out of all this work, sort is actually taking 32%. Sorting data, aggregating data, and doing any kind of math and any kind of expressions is very expensive for the CPU to do, because doing things like this, they're pretty much defined and hashed and indexed stuff that normally involves the I/O, because we just read the data from the drive, put it somewhere in a buffer, and then dump it out to the client. Whereas once we start doing any kind of manipulation to the data, we get into the realm of recomputing stuff, which is why sorting takes 32%. Even if we start actually adding more stuff to sort, let's say we want to sort it by cost rate, add stuff to it. It doesn't, well, it's actually changed it because it now added a location into this loop, which added the overall cost to the query. That's why the sorting kind of reduced. Let's get rid of it and let's order it by, I don't know, days to manufacture, stuff like this. Start adding stuff to it, the cost of sorting operation doesn't actually change. If we reverse their orders and things like that, then in this specific circumstance, the cost of sorting doesn't really change, because it basically depends on the number of rows and the difficulty of sorting. In our case, we're sorting by order quantity, which is not as difficult as sorting by var charts, but still, it's quite an expensive operation. Okay, and generally, if you can avoid sorting on the SQL Server side, do it. Because, for example, in our case, our customers are sitting in multi-tenancy environment. We've got one server with many customers. If we're doing a lot of CPU operations on the server side, it's kind of bad. Let's sort it on the client side, or even when we're working with something like Event Dispatcher, where we have a job running on our server. Our server, within the code, you can manage that sorting and how much resources you take a lot better than just asking SQL Server, well, throw everything you have at sorting my data in this specific order because I want to get it in that specific order. Well, screw it, do it on the client side. Right. Another thing is I wanted to mention is a so-called deferred scalar expression. So if we're doing something like this, we're going to actually sort by quantity plus 1. I know it's a bit daft, but let's do that. And what we're going to see is a scalar expression computation happening after we select the data from product inventory. It kind of asking, I'm asking myself a question: why the hell did it do this? Why does it need to do the scalar computation from the as an output from our product inventory table where all it needs this value is for sorting. The sorting happens almost like independently, after we got all the results back. So why do we need that scalar computation? Well, if we actually read if we read into the execution plans and how the SQL Server compiles this query, in this specific case, this is becoming like a deferred scalar expression, which means that we're only going to need it, we're going to refer to it when we're doing some further computation. So it saves us time on our sorting routine, because now we don't have to do any more math there, because we've done that math there while we were selecting this data. And it makes the sorting a lot quicker. So SQL Server is quite smart when it's doing things like that. Generally, you can tell, like, for example, of course, if your query becomes very, very complicated, you use things there and then from there, etc. You're joining them, merging them, or you're doing things like that. Then, yeah, it's very difficult to kind of understand what the execution plan is doing. But generally, if you have any kind of expression, expect that expression to be either scalar computation right after your initial selection from a relation, or you might see it actually happening just before the sorting if your query itself ended up not using this scalar computation, or basically filtering the data down so much that you don't need that computation happening right after the selection. I'm going to get too deep with this stuff. Anyhow, okay. So the next thing I want to discuss is selecting a specific range of data from our query. We could do that by simply saying, give me only 10 rows from the top. It gives you only 10 rows. Simple, right? So when you're saying, give me 10 rows from the top, for example, or 100 rows, or 1,000 rows, or 10,000, I can go all day like this. 100,000 rows, a million. Okay, we can say, give me 50%. Okay, so it's all very cool. Again, if we start using looking at the execution plan, you'll see there's no magic happening. All that is happening is we're still selecting all the data, blah, 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 up to the sorting routine, where we're saying we only need so many rows. And you can see the actual cost of the sort operation is still the same. So everything up to the top bit happens exactly the same as without that top bit. It's just when we actually select the data out of it, we're going to output only 10 rows. So this contrary to what a lot of the very daft articles on the internet say, well, put top 50% and it will make your query run faster. No, it doesn't. It makes no difference whatsoever. In fact, it might even make it run slower, because you need to do further analysis before you output the data. And even slower is putting 10% on it. Why do you think it's even slower if you put 10% on it? Exactly. It has to do another calculation. How many rows do we actually have? How many we have to output? So it will be even slower. You can see we now added another bit to our execution plan, which is top something. Okay. So generally using the percentage, especially in a very large data set, is, well, not really good. Very good. Avoid it if you can. Generally, almost never seen them being used. Okay. Moving away from the execution plan, it's pretty clear what the execution plan is doing. What happens with the top is it will select the top row based on your ordering as well. So if we want top rows, if we want 10 most stocked products, for example, then we can order this by our inventory in ascending order, and that will give you top 10 stocked products. Descending order, sorry. So there you go. That's how you get like top so many products, top many sales, and so on. Top just products. We can order it by, I don't know, let's say product color in descending order. That'll give you, I don't know what it gives you. It's just basically black because it's at the top. If we, huh? Of course I do. I'm sorry. This is daft. There you go. is null. We say is null. When color is null, we turn it into pink. Okay, and it disappears. Yeah, and if we look at our execution plan, we'll see some nonsense happening. Wow. Can anybody tell me why did they decide to do the sorting before the loop? Before joining that to a product image table?
Because you're sorting the color and then you'll be able to turn on that to be able to sort it personally. Not about the frame.
Yeah. No, you're absolutely right. It's to be honest, I didn't expect that. It's very as I said, SQL Server is pretty smart when it actually does the estimation. Works out what's the best route for actually executing this query. And here it actually figured out, you know what, we only need top 10 products out of our... Actually, it doesn't do the top. No, it's not as smart as I thought. Okay. How many rows do we actually get in here? 504. And then we sort 4 rows. Before the nested loop, and then how many scans do we do? 10 with 4 executions. I literally haven't got a clue what it's doing. I think it did actually throw away. Scalar operation. To be honest, I can't even tell you from this execution plan. I think you need to dive into even further and trying to analyze what the hell is actually done. But I think it actually put the sort in there, but not rows. Why is it 4 rows? Anybody? I haven't got a clue, to be honest. There you go. That's SQL Server execution for you. Oh yes, because there are 4 different products there. Yes. Sorting. I think, to be honest, I think this, in my view, I mean, based on what I'm seeing here, I think the execution plan, the drawing itself is a bit wrong. I think it actually did the top sorting there with the predicate. I don't see the predicate in here anywhere. I don't see the predicate in here anywhere. But somehow we ended up with only 4 rows, which kind of suggests to me that it did the top filtering at this stage before it got there. Top 10 is basically selecting top 10 results out of the Cartesian product. Cartesian product being cross-join, effectively, well, joining product with the product inventory. So although we selected 4 products from the products themselves, because we only got 4 different products that match pink, black. Shouldn't make any difference. Anyhow, you're gonna have a lot of fun with execution plans, trying to analyze what the hell is happening. Okay. Anyway, what I want to sort of mention as well, I don't think we'll go through everything this session, but is subquerying. So subquerying is, let me just try to get a little handle on. Oh yes. So subquerying is where we can do a query. Let's get rid of that. Okay. We can write a query like this. Oops. See what I've done? Production from production product inventory. And join production location, give them names, on location, product ID, and then inventory product ID. Okay, from here I want product ID, I want location ID, I want location, say name, and inventory, of course, quantity. Okay, so I can just run this query independently like this, and what I'm getting is product ID, location ID, and how much stock we've got in that location ID. It's pretty much what we're doing here, wouldn't you agree? Pretty much exactly the same from SQL Server side of things. Really, it's exactly the same. So what we can do is we can replace this in a join with a subquery. Subquery is meaning that instead of actually specifying a specific table, I can say do something like that. So I want to give you a result set for instead of a table. Remember in the previous session we were talking about the predicates and views that those that those restrictions can. Is it called restriction? I think it's called restriction. Restriction is the select basically in relational algebra. So we can do a restriction on the relation, get some data back, and we can put it in a view, and we can use that view effectively in the next restriction. So that's pretty much what that is actually doing. From the TSQL side of things, so this is where we actually program when we write the SQL server. This is what it looks to us. So those, we create a specific view. That's our subquery, and then out of that view, we dump some data out to use in another in the join, let's say. So now I can get rid of those things, and I can call it sub inventory, just to give it a different name. And that pretty much gives me exactly the same result. Get rid of the top. Gives me exactly the same result as I would have when I had those inner joins. In fact, if we now look at the execution plan, you see that nothing really changed for the SQL server. It still knows that we still have to scan the product inventory, product location, but from this output, we don't actually need the location or location ID, so we don't even need to include it into our scan as well. So it's pretty smart in terms of it actually decompiled this subquery. It doesn't just do the selection out of that subquery and dumps all the data for use in all the other queries that up the chain. It actually decompiles this whole thing into those predicates, and this is how it can determine the fact that you don't actually need to do this selection. It doesn't do exactly what we would do. Select this first, get this table, and then use it to match it to products. Look at the execution plan, it doesn't do that. Now if we include something like sub inventory location ID in here, we'll see that just we now added the location scanning. Probably a nested loop is going to appear as well. No, nested loop didn't appear, which is good. We're doing didn't do that. Okay. All right, so that's basically a subquery, and we can use them pretty much everywhere, and we can do things, really retarded things. Now I'm going to show you something that you should never do unless you absolutely have to. It's called using I don't know what it's called, to be honest, but you can use the subquery as an output of your attribute. So what we can do is this. Let's say we want to produce next work order due for a product. And instead of just basically computing this value, I can say, you know what, I'm going to actually do a select. I'll say select top one, due date from production and then there is a table called work order. Product ID equals, let me just select all the products first, and that's sub inventory, quantity ascending order. Tick. Let's see if this product here has got any work orders. Doesn't. Remember, I've seen one. Let's try this one. Don't have that product ID in my notes. I thought I had, but I don't. Okay, so if we just basically specify something like this, we'll get one order by due date descending. Wrong. This is right. Okay. So what I'm going to do in this specific query, I'm selecting the latest due date for a product to be produced, manufactured, for this specific product ID. So you use this query in our output there. But now, basically, I'm making this query for a specific product, this product 726. But what I can do is I actually use an attribute of our query as a, well, basically as a predicate in this query. So can anybody tell me what this is actually going to do?
So let's select every single output. Yeah, it's going to execute that select every single output.
Yeah, from the execution side of things, it will do exactly this. But in general terms, what I'm trying to achieve here, do
so get the Aliases due date for the product.
Yeah. So for every single particular product, I want their due date to appear, the latest due date. So being a very daft person, I just put it in the SQL statement. I can, right? So nothing wrong with that. So execute it. Let's look at the execution plan. Whoa, got a little bit bigger, right? Just by putting that SQL statement in there. And we're going to actually look into this. If we analyze this execution plan, you will see that's what happened. Or what happened is I'm executing this query individually for every single output. It's really daft thing to do because now let's look at where we actually execute this nested loop on 1064 rows, and that will be executed so many times on the work order. So the work order output is going to be 1, but then she's done some computation there, but then we're going to be basically scanning it 428 times. That's because we've got 428 products with the work order. Everything else is effectively null. Yeah, we're just doing that. I mean, you can see that this specific bit is actually taken most of the time. And it's okay if you've got 1,000 products, but imagine you've got something like 1,000,000 products and you want to get, and you then go, I want top 10 products with the with the due date coming up or something like this. And yeah, on your development environment, it will actually work with like 1,000 products absolutely fine. When you put it deployed to a customer, the server will probably kill itself and shut down and never restart again, because this query will just be absolutely insane. You'd have to run this query, basically this scan, almost like 1,000,000 times. for every single row. Of course, it will optimize the scans as as much as possible. It might even decide to, that this is going to be our primary scan table because so many loops we have to do from the estimation plan. Might even decide, we don't need to scan this. We need to kind of put this as a almost as a join, and the SQL server might be smart enough to determine that that's what we actually need instead of putting it as a separate attribute subquery that outputs the attribute. Might even actually just do a join on it. But in this case, it didn't because we don't have that many rows. So it's a really good example of how to do this. Okay, I think we're out of time, so we'll move getting the row numbers and grouping for the next lesson. I'll adjust the homework specifically.